My name is Johnson. We already had an introduction, so I'll skip that. I'll move on to the presentation. This presentation is about how do you validate the Linux kernel in Azure using KernelCI. In this, we'll talk about what is the test framework we use and what is the strategy we follow to validate the upstream kernel. And again, we'll see how do we improve the coverage for the upstream kernel validation, collaborating with KernelCI. So we'll start with the objective. The goal, right? So the first goal is like stable kernels are released on a weekly basis, and we want that this kernel should be tested automatically through KernelCI. The community has 2 days window to test and provide the feedback, and the end goal is to provide a consolidated report showing the quality of the stable kernel. So what are the challenges for that is, the challenge is basically in KernelCI, today we lack the validation of a stable and stable RC on the cloud environment. And what is there is only the build and the boot test results are being basically shared with or reported to the stable team, but that too as a manual process right now. And there is a lack of an automation for driving the result failure triaging and the reporting. Now, how we are going to solve this problem? So basically, the solution is to enable the testing of stable and stable RC in Azure Cloud, then empower and enable the developers and maintainers to run the validation on cloud. And at the end, KernelCI should be able to consolidate the results from the Azure as well as from the other publisher to consolidate and generate one condensed report for the maintainers. Right. So let's see, how do we leverage KernelCI to validate the Linux kernel in Azure? So Gustavo touched about this architecture. Minas also talked about briefly. So I'm not going to take much time on this one. I just wanted to highlight the two important parts in this one. Both are being bordered by a red rectangles, right? So basically, we are into a CI ecosystem. That is, we are not inside KernelCI, but we are monitoring the events from the KernelCI that is published by the Maestro. And what we are doing is basically Maestro publishes a lot of events, like checkout event, build events, test events. And in this one, we are monitoring for checkout events. So we have a pipeline which is constantly, so we wrote an app or application which is monitoring the KernelCI events, and we are receiving the checkout events from the Maestro. So what happens once we receive is, this is the workflow. So once we receive this event, basically, we kick off the validation pipeline. This validation pipeline is comprised of 2 stages. First is basically to build the kernel. That is, in order to build the kernel, we take a stable image in the Azure so that there is no noise in the test, and we deploy a VM, and then in that VM, we use the commits, branch, and the tree information to check out the source code, and then finally build the kernel. Once the kernel is built, then we capture the VHT and then put it into a storage blob. Now, this is the candidate to be tested, and now what happens is the second stage starts, which is basically it runs the Lisa test. In Lisa test, basically I'll cover the details of Lisa test in the next slide, but what we run is we test, first we run the boot test. In boot test, what we do is we enumerate through different VM sizes in Azure and verify that those are booting well. And then we do a functional test. So functional test, basically, I'll talk more about the functional test in the next slide, which has the details of all the tests and the test area which are being tested. And then finally, we run the performance test. Currently, as of today, we are running network performance test. And the intent is to make sure that the throughput, right, on the Linux VMs is as expected, and there's no regression. So once we complete this test, the test results are published to KernelCI DB, and then the results are available to community through the KernelCI dashboard. So this is the overall workflow for basically the KernelCI integration with the Lisa test. Now, if you see this, where are we now? So basically, the results are published to the dashboard, and you can see the origin as Microsoft. And now here, basically, we can go into each test and get the test results. And even the test results which is published also has a link to the test that you can access and directly go to the test case directly, which is publicly available. So far, basically, we are monitoring 5 trees. That is mainline, next, stable RC, and Hyper-V tree. And then basically, we are testing validation for 19 branches. this is about what are the tests we run for the Linux kernel validation. So Microsoft Linux team has developed a comprehensive set of tests that is referred as the LISA test. The LISA stands for Linux Integration Service Automation, and this is specifically to validate the Linux in Azure cloud environment. Now, LISA is completely open source, it's publicly available, and community is encouraged to contribute tests to that. So what we do as of today is basically in LISA, different tests are there, and each test is being put into different test areas. Now, in KernelCI execution, in the upstream validation, we are not running all the test area, but we have handpicked few stable test area and test cases that we are running. So as of today, we are running the core, GPU test, LTP, provisioning, time, nested test, network test, and storage and SRIV, that is accelerated networking test. Now, this test, how do we select this test? Now, this test is basically, test tiers are selected based on the scope and the time budget. Each test has a priority based on the importance of the test, which stands from P0 to the P4. And so basically now, all these tests basically are being now put into a different tiers. Now, what happens is each validation is being driven by certain constraint that it can run for this time. It cannot run infinite, right? So based on that, we can decide what test tier to pick. So if you see T0, when you select T0, it can complete in 5 minutes. When you select T1, it can complete in 2 hours. When we select T2, we can complete in 8 hours. So it will depend upon what is the time budget that is being allocated for that validation, and the appropriate basically tier can be selected. In this case, as of today, basically we are running tier 2 selective test. It takes around roughly 3 hours for us to publish the results to the KernelCI DB. And as I mentioned, the stable Linux image is used in the fleet for validation. Now, when we integrated this, the monitoring app, what happens is we are listening for checkout events. Now we are going to get the checkout events for all the tree which is already onboarded in KernelCI. And do we want to test all? The answer is no. We want to, to make a proper use of the resource, we need to enable the validation for the trees which are critical and which is required over here. So in order to address that challenge, basically we introduce a concept of a configuration file. And that configuration file is a structured configuration that defines the tree, branch, and the architecture that needs to be tested. And basically, when we receive checkout event does have a lot of, that payload itself has the information, what commit, branch, trees, right? And then we use that to match with the configuration and see, is this there? That needs to be validated. And if it is a match, so basically then we start the validation. Now, here you can see architecture, that is not coming from KernelCI, and that is basically, we added as saying that, okay, let's run it for the ARM64 and x86-64. So those are like how we are filtering out the checkout events that needs to be prioritized and validated. Where is this configuration file? Right now, it's an internal repo, but our end goal is to put it in the KernelCI repo so that community has an access and they are empowered to modify it, enable the new branch tree they want to monitor, and that can be very well done through the, basically the modifying this configuration file in the KernelCI repo. So this brings me to the next, what next? We have already integrated, we are publishing the results, and we do have a coverage for stable and stable RC being published. So what next is, there are a few things which we want to improve. Right now, as I mentioned, we are running a boot test with the different VM sizes. But those results, like basically, recently we figured out there is a new object, like an object is there, like a boot object that needs to be, that we have to send to KernelCI for that to be listed as a boot test. So that is missing. We need to implement that and publish the boot test results. Then KernelCI DB is moving to the REST API. That is the next thing what we want to do. And then basically, as I discussed about the test configuration file, that we want to move to the KernelCI repo. And next is basically, how do we increase the test coverage? So basically, right now, we have handpicked the tests, which are very stable, less noise is there, and gradually we want to, based on like the execution, we gradually want to increase the test coverage to get more and more coverage from the different test areas for the upstream kernel validation. Yeah. So now, what is the support from KernelCI? Is there are few things that we can enhance in KernelCI infra as such. That is basically right now, even basically. Gustav was talking in the very beginning, right? He was showing the configuration that the tree, what is missing over there is like CI subsystem information. like if there is a possibility to enable a CI subsystem information as part of that configuration, then the need for maintaining the configuration file, which I explained, is not required. So we know that, okay, this is intended for this CI subsystem and this should run. So we feel like if that is there, that would be a very good solution. We don't have to maintain an additional file. Now, again, I talked about the test tier. Based on the time budget, we run the test. So now that is basically in KernelCI, if we have a way to define or quantify that for this tree, based on the importance, we want this results by this time, or how quickly we want the results, or what is the depth we want to go. So basically defining the time budget allocated for validation is going to help us with that, and we can very well expand the test coverage based on that. The email notification subscription, there was a lot of questions in the very beginning about the email notification. So basically this is also something feel like with the checkout, if we can get, we can also send out an email notification for the test completion, right? But these are good to have a feature. And then there was one more question from Tim in the very beginning that UI, is there any UI to see the test case and the test plans, right? So we are thinking of like, can we enable that feature as part of a KernelCI that the community has an access and visibility of what we are running, rather than looking into the test results, rather before test results, we can look into the basically UI, and if it possible, we should be able to select as well, right? So we are thinking like, can we enable that UI support for configuring tests from KernelCI UI? I think that's it. That's it for today. Let me know if you have any question.
Yeah, regarding the configuration file and having the information more readily available for what's going to be tested by each origin is one of the the feedbacks that we've been working and receiving since we brought in this new KernelCI. It will have to go through the limitations that we are solving KCIDB right now to have that kind of information. But it is something that we've been hearing from the users, right? They want to see on the dashboard, oh, this is gonna finish hopefully in 3 hours, expectation in there, right? It's spinning, it's running. Because right now, if you go to dashboard, some of those trees there, maybe for the Microsoft origin, you send out your test results at the end of the execution. Yeah. For other origins like Maestro, we keep sending updates into KCIDB as we go through the test executions. So if we start build X amount of trees, we tell KCIDB that we are running those trees, those branches, and the number of configurations. And then we send the complete build events. And then we send the boot start events. Not events, but filling in things in the database. So growing that kind of a functionality, I think, would be pretty great for KernelCI. But we need to sit down and scope it and talk about it.
Sure. In fact, that is possible, right? If there's a way, once we receive the checkout, we kick off the validation, we can send the event to KernelCI for notifying the status. Test is started, in progress, where are we? And if that is being defined by KernelCI as a, let's say, okay, I'm expecting this kind of an input, definitely the test framework or the test pipeline what is running, we can start publishing that events as well for KernelCI to update the real-time status, how that's going on.
Yeah, we can work on that, that's for sure.
So you talked about making once you got the results and then being able to make testing available to the maintainers and developers. What's the workflow for, if I'm maintaining a tree, I've got a failure, now I'm trying to debug and I'm trying to go through that either as a maintainer or developer. How's Microsoft handling getting access to those instances and reproducing the tests?
Yeah. As I mentioned, in the test results which is published, do have an access to the link to the test.
Yeah.
Okay, and we can access the test from there. But again, as we're discussing, how do we generate a condensed report, right, for maintenance? We don't, there could be n number of origins publishing the results for the same commit, right? And might be quite tedious for maintainer to go and run behind all the, basically the regression. The first level triage should happen at the KernelCI, and once basically that happens, and if still maintainer wants to check, that result is available from the KernelCI dashboard, we can go to the metadata, and then from there we can go to the test case itself. Logs are also published, And even the now we are working to enable the serial console logging as well,
Yep.
so that you will get more real-time data of from the kernel log perspective.
Okay, so that's the reporting. Got the details of what failed on the test cases. Now I'm in the process of fixing the problem, and I've got to run it before I start pushing out to a tree that's regularly getting tested. Are you making access to be able to reproduce running the tests when I make changes on my local tree, so that we've got that full development cycle, go fix the problems, solve the thing that's failed before it then goes out into the regular testing tree?
Got it. Okay. So that will depend upon how KernelCI triggers the event, right? And we can very well.
So you're expecting to do that through
Maestro
KernelCI.
to trigger the event.
Yeah, that's behind the vision of KCI Dev and having the core orchestrator there, because we want to allow the maintainers to have a token to KCI Dev, so they can talk to the orchestrator, to Maestro, and then if they push a branch to some tree that you have, we could test that special path they put on top, right? And then it's up to the CI systems listen to that to allow that testing to happen, right?
How open is that going to be? How open is that? Are you intending that to be? As in, are only maintainers going to get those tokens, or is it going to be a little bit wide where we want to get those out to developers so developers go solve the problem instead of maintainers, who are all overloaded anyway?
I think the main limitation is security, right? Because we have a lot of labs, a lot of hardware systems out there that we can't just hand over tokens for people to run whatever patch it's in there. We didn't discuss that much yet, but my initial idea is that if we have a kernel.org account, you may have a token. If you're not, then we need to discuss case by case.
So asking about the open part, for example, Sysbot does this. Sysbot, if you have a report that comes in, pretty much anybody can submit. They could just reply to the Sysbot bug report and say pound test, just say sys test, and then give the Git repo. So it is that easy. So do you not want to be that open? Because I use that feature a lot myself, and then also a lot of the new developers use it.
I feel that works until the first person abuses it to mine Bitcoin or something.
I wonder how Sysbot is handling, Syscaller is handling it.
Bitcoin ruins everything.
Okay. But anyway, so that feature, that openness has been helpful for a lot of new developers to be able to test stuff, because all the bug reports and then test. But it could be different.
Yeah, just one thing. Because it's a lot of players in the ecosystem, right? It's not KernelCI who has the lab; it's a bunch of companies that have their labs. So if we incur a huge amount of cost on a company because they didn't really prepare for that, that's.
Yeah, and maybe it needs to be on both sides, right? Because you need to be able to say, I want to run a test, and then we on our side will need to make a decision of whose requests we're going to execute, and then it's going to be the trust between the two sides.
And I can see that the scale issues are very different. Microsoft, you've got Azure. You can spin up instances quite easily versus a physical board lab where you've got 50 boards and that's it. So the decisions on who gets to do that become very different, I imagine.
It's actually a few hundred, but still.
Yeah, you know what I mean.
Thank you.
Thank you.